Hello friends, welcome you back to my YouTube channel once again. Today I'm going to teach you how to code for the OR gate. Before that, let us have a quick revision of logic gates. So what is a logic gate? A logic gate is a built-in block for every digital circuits. So they perform basic functions or complex logical functions, and then they are fundamental to the digital circuits. And there are so many logical gates like AND gate, OR gate, XOR gate, and NAND gate, and so on. But today we are going to discuss about OR gate. So what is an OR gate? OR gate, it is a logical gate that will perform a addition of bits. The output will be high, that means the output will be 1 if any of the input is high or if both the input is high, whereas the output will be 0 if all the inputs are 0. In order to understand better, let me show you a picture. So this is the OR gate. Here in the OR gate there is two inputs, A and B, and then the output is Y, A plus B. The function of Y is A plus B. Okay, so you see the truth table. Inputs, if both the inputs are 0 0, then in the output we are getting 0. If any of the input is high, here B is high, that's why the output is high. Similarly, A is high, that's why we are getting output as high. And if both the input are high, then also we are going to get the output as high. So let's go ahead and write down the code for this OR gate. So let me follow this block here. Let me begin with module, and then OR gate, name of the module is OR gate. So in this port list we have to declare what are the signals. A is the signal, B, and then Y is the signal, and module. And then we have to declare the signals that belongs to input and then output. So input is A and B is the input signal, and then output reg, that is register, and Y. Now you will notice that why we are using this reg. This reg means they are going to hold the value of A plus B. See here in the block, Y is on the left hand side. On the right hand side, that is the expression. After this execution, this output will be stored into the Y. So they need to hold the output, right? That's why we have given as a register. Now this OR gate, it is a combinational circuit. So the combinational circuit, it depends upon the present input. So always at the rate of present inputs are A or B. Okay, and begin and. So whenever there is a change in the value of A or B, the output will get updated with the latest values. So Y, that is output, is equal to A logical OR and B. Okay, so Y is the output, A logical OR and with B. So in mathematical term, like we can define it like this way: Y is equal to A plus B. Okay, so this is the logical symbol of OR gate. That means they are going to do the additions of A or B. Now we'll go ahead and then write down the test bench. Module TB is test bench and module. So in this case, what we are going to do is that we have to declare A and B as register. Okay, whatever is declared as input in the design, we have to declare those signals as a register, A, B, and then the output in the design will be declared as a wire. So wire Y. After this, what we have to do is that we have to instantiate this design into the test bench. We have to bring this design into the test bench. So write down the name of the module, ORGate, and then we have to give the name of the instantiation. That's why I'm going to give inst1. You can write any name, okay? And then you have to list down the port A, B, and Y. So I'm instantiating this value in the form of position. So here instance by position. Okay, now after this we have to provide the stimulus initial begin, and that means we have to provide the input. So a is equal to 1 tick b. Okay, that is the number of bit, that is 1, and then this is the radix, that is the bit, and then we have to give value. B is equal to 1 tick b 0. I'm following this truth table out. I'm following this truth table. Okay, so let me go ahead and then write down. After one transaction, let's give a 1 nanosecond. Again, we are going to give, let me just copy directly this one to save time. Copy, paste it. We have 4 transactions. So initially 0 0, next we have 1 0 1 0, next we have 1 0 0 1, and then next we have 1 1. Okay, so I'm following this truth table. So this is the stimulus, these are the inputs we have given. Okay, and then in order to view the output, what we have to do is that we have to use a dollar monitor to view all the input and output. So I'm going to enlarge the window here by using this dollar monitor. Here let me give, let's see the time as well. Okay, t, that is the time. A is the format specifier of binary, b as format specifier of binary, and then y as format specifier of binary. Dollar time and a, b, y. So these are the signals we want to view. After this, let's select the tools, that is all is already selected. Simulator is synopsis. Now let us run this. Okay, now you can see here when it is 0 0, if the input is 0 0 and the output we're getting 0 0 1. Let me bring out the image here. Let me put it this side. Okay, during 0 0 we are getting 0, so here similarly 0 0 0, and then 0 1 0 0 1 we are getting 1 1. Okay, and 1 0 1 0 we are getting 1 in the output, and then 1 1 in the output we are getting 1 1 is 1. Okay, so this is the working of the OR gate. I hope you will like this video. Thanks.